And Carlton, that was an awesome presentation, and I definitely want to talk to you a little bit more because I know a lot of us folks have similar desires and visions about improving our program. And I hope y'all have enjoyed the conference so far. I know I certainly have, and I typically really enjoy some of the national scale research that you hear about at this conference because it has broad applicability. But I think it's useful to realize that a lot of states do their own stormwater related research, and oftentimes you don't hear quite as much about that. So that's what I want to spend a few minutes with you today talking about NCDOT's stormwater research program. I really like Carlton's presentation because you kind of heard his vision of where he thinks his stormwater program needs to go in order to really improve efficiency. And that's really the take-home message that I have is stormwater research really can form the foundation of improving your NPDES program. I think it's really critical, certainly critical for ours. Here in this picture, you see our research team at the North Carolina State Farmers Market Restaurant. And we found that when we've got a really difficult problem to solve and research is needed, we do our best thinking over grits, scrambled eggs, and pork sausage. So that's worked out well. We do have a stormwater research plan, and this is kind of a high-level plan that describes our approach, how we go about funding research, but I pointed out to you simply because if you're interested in a reference to see what all of our research we've done over the years, this is a good place to go. It's a convenient place to see them all listed, including our erosion control research, which we've done quite a bit as well. Coupled with that plan, we've got a quality assurance project plan, which is really critical as well, because you want to make sure your research is defensible. Now, when we approach our research program, we set goals and we try to think about how we approach the research in a logical way. And we've come up with this sort of illustration to kind of show you how we approach our research. At the very top there at the 12 o'clock position, we think about research in terms of characterizing the problems. What do we don't know? What do we need to know? It could be something like, what is the pollutant load for nutrients or phosphorus coming off the roadway? We need to characterize that, that issue. Because that's important to know, because when you continue down the cycle here, you want to evaluate, next you kind of want to evaluate some of the BMPs that you have in your existing toolbox. How well are those performing to say remove the phosphorus? That's useful to know to make your decisions. Then once you got your standard tried and true BMP design, is it working as good as it could? Just like the ponds. They've learned in Florida, the ponds seemed like a good idea at the time, but maybe they're not quite working as well as we hoped. So maybe we need to think about optimizing our BMPs in some situations. And even if you optimize a BMP and understand how that works through research, then sometimes it's good to say, okay, we need to rethink the whole BMP concept in total and come up with a whole new type of BMP. And research can help with that. And then finally, research is useful in our view, in terms of improving your programmatic processes and your guidance. So we use that for that purpose as well. So for the rest of this presentation, I'm going to kind of go through and give you examples of how we've used research to address these core goals as we move forward with trying to improve our NPDES program. Again, the first one is characterization. Many of our research programs have a characterization component. How much zinc is coming off of our roadways, or how well does this perform? But the one project I want to highlight for you here in the characterization category is one that we did in partnership with USGS to characterize stormwater pollutants coming off of bridges. This is one of the nation's largest characterization projects off of bridges. And it also incorporates an interesting component of what effect did those pollutant loads have in stream on the biota. And the reason why we want to have this understanding is we've got practical questions like this. Is a closed drainage system, which is very expensive to maintain, do you need that? Can you directly discharge and still be okay, or could you do something else? Research helps you answer those projects, those types of questions very effectively. Evaluating the performance of BMP designs. We've done quite a bit of this, and what you see in the picture there are bioretention basins that were constructed near a bridge to treat the bridge runoff. And in North Carolina, we have warm. Oh, wait a minute. That's not what it says at all. There we go. I'm sorry. There's your two bioretention basins. We have warm season grasses in North Carolina. In the wintertime, they go brown, so that's why everything looks kind of brown, but rest assured it will turn nice and green in the summertime. Here are some monitoring boxes that we have here to do the sampling, but this is basically a basin that detains the water, and then it filters down through about 4 feet of engineered media, mostly sand, as John described this morning, and then it's treated and released. This basin here on the left side there is to full design standards. And then the one on the other side right next to it is half that size. So the question is, in terms of characterization, is a basin half the size any good at all? It's not to what the regulatory agencies would accept. Is it any good? Is it half as good? So those are the kind of questions that we answer. It turns out it's about 75% as good as what we kind of landed on. But what was very important here is we got the regulatory agencies to allow us credit for BMPs that are undersized. And this was a very new concept to them. In terms of BMP evaluations, here is an example of some evaluations that we've recently done related to erosion control. You know, you put out your straw on your disturbed land to keep it from the dirt from eroding away. And typically we'll go out there with a small cannon and spray emulsified asphalt all over it to keep it tacked down. Well, is that good for the environment, spraying the world with asphalt? So there's a lot of products out there that claim to be good at binding straw together, but you know, are we just going to accept the manufacturer's word for it? So we've done a lot of evaluations using wind tunnel tests here in these various products, and now we know for sure which ones are good and which ones are not. Very, very useful type of research. Open graded friction course. We're very excited about this. Open graded friction course has been around for a long time. It's a hot mix asphalt blend that does not include very much fine. So really water goes straight through the initial layer of it and then migrates laterally off the side. And what it's originally developed for is for safety. It reduces spray. But what we have found that because of that reduced spray, the reduced undercarriage washing, we're seeing some benefits to water quality. And this is what an experimental setup here to evaluate that. We see really good TSS reductions. It's kind of a mixed bag in other areas, but through this research, we hope to add open graded friction course to our BMP toolbox and have that recognized as a BMP. Ocean outfalls. We are a coastal state. We've got beautiful beaches, but there are a handful of direct discharges to the swimming beaches, and it's not the greatest thing in the world when these signs go up warning the swimmers that there could be a health hazard swimming next to the DOT outfall. And the local government leaders are typically not very happy about that. So one of the research projects that we were interested in doing, we put in some infiltration chambers in the dunes to capture that water and try to infiltrate it. But was that enough? Were we really protecting those swimmers? Could that bacteria that's very, very common in all stormwater be migrating laterally into the swimming zone and still present a risk to the swimmer? So we researched that for several years, and we can now say with confidence that this sort of technology is protecting the health of the swimmer. So that was a really great success there and something that we're quite happy about. Moving on to optimization of B&P designs, and how do you go about doing that with the aid of research? This morning, John gave a great presentation on sort of linear bioretentions. We call them bioswales, but it's really almost the exact same thing, and we design them in a very similar way. But the question is, how long do you make them? What's the optimal design for that? So we're working with NC State University to look at various lengths across various slopes to create a mathematical, kind of a spreadsheet-based model to help optimize the design so the designer can run a simple tool and figure out how long they should make the device. But these are, as John mentioned, these are great devices because, as he said, if you can fit in a ditch, you can fit in typically one of these bioswales or linear bioretentions. So the more that we can bolster this kind of device and have it recognized for its full benefit by the regulatory agency, as well as shrink them in size as much as we can, is a big win-win for really everybody. Here's an example of erosion control B&P optimization research. You know, a standard element in your erosion control design are these diversion ditches that lead to your sediment basin. But what we were finding is often the biggest source of sediment that was filling in the sediment basin was from the erosion of the diversion ditch that we were designing in. So we're looking into, you know, things like, you know, spraying asphalt, a thin layer of asphalt, or using Excelsior blankets to reduce that erosion and really enhance the life and reduce the maintenance that's needed on these sediment basins. We do a lot, you know, the state soil in North Carolina is Cecil clays. And we've got a lot of clay, a lot of turbidity, and we use PAM, polyacrylamides, to reduce that turbidity. But how do you dose that turbidity when you have somebody out there sprinkling as it rains? You need to have a good mechanism for doing that. This is a really clever device that was actually originally developed in New Zealand, and it requires no energy. It's a mechanical doser, but it doesn't require energy beyond the energy that is provided by falling water. And it's got this little roof on top there that provides the source of water to blend the polyacrylamides and dose it. And the really clever thing is the size of that roof is proportional to the drainage area. So you can kind of get a dosing that's consistent with the flow coming to your site. So some really interesting research that has helped us a lot in the erosion control arena. We also heard this morning a presentation about maintenance and PennDOT and some of what they're learning about maintenance. And it really is a hard thing to get your handle on. Here is a dry detention basin that is maintained as you normally would with mowing, a standard vegetation management approach. And again, that's a lot of work. What happens if you don't mow it? What happens if you let kind of trees grow up? Is that a bad thing? You know, John mentioned that having those weeds growing up in his linear bioretention, he loved them. Well, it could be that these trees are actually providing a benefit to us, but we don't know. We can't just hypothesize that to the regulator. So we're doing some research to see if we allow a basin to grow up, is it actually going to provide enhanced treatment? Maybe not, we don't know, but that's what the research is going to tell us. New BMPs, we use research to kind of help develop and justify a new class of stormwater BMPs. And one of the things that we're really interested in North Carolina is how can we give some functional uplift to the roadway right-of-way as it is currently kind of built without having to build big basins and those sorts of things. So one idea that we come up with, and it's sort of inspired by some work that Washington DOT has done with ecology bankments, but one of the things that we're interested in is, can you improve the soil in your roadway embankment to increase infiltration? You know, when you're building a road, you've got mass grading going on, and in some cases, you've got soil that's been brought up from the depths that hadn't seen the light of day in 100 million years, and it's nutrient poor and it won't grow anything. And it's just not a good thing. And then we compact it to all heck, and you can't get any water into it. But if we can improve that soil through tillage and some sort of amendments, maybe we could increase the infiltration capacity of our existing right-of-way embankments. So what we have found through this research is that tillage works and adding compost, that sort of thing works, but only for a limited time. And then that functionality drops off because of recompaction, the mowers. But what we've subsequently found is if you can get a good vigorous plant growth on top of it, then the infiltration is sustained, and we've seen that. So what we're doing now is, if we know that plants are good and improving the soil is good, can you make that even better by incorporating pollinators? And I know a lot of DOTs are very interested in pollinators for a variety of reasons. Our wildflower program in North Carolina is wildly popular. It is hugely popular. People buy specialty license plates, and that funds that program. And that's great to have pretty flowers, but not all flowers are the same. You know, there are some flowers that bees and other pollinators really go to, and others they don't go to much at all. So our idea here is, can we create a new class of BMP that promotes infiltration, which is good for the environment, is pretty to look at, which is good for your citizens, and is a very effective source of food for pollinators. North Carolina's #1 industry is agriculture, so there's a lot of intense interest in the agricultural industry, especially aimed at the DOT, to provide more pollinator habitat. So we're trying to do that through this research. You heard this morning Everett's presentation on our biofiltration conveyance. I won't dwell on that because he did such a good job of it, but it's essentially, if you didn't see that presentation, it's a steep slope BMP that includes a series of step pools underlain by engineered media to try to push water down, to filter it, and either infiltrate it or have it laterally move down the hill and filtered even more. And this has been one of our most effective BMPs. We've had PhD level research done on this, and it's been one of our most effective BMPs. It's really cool to see water come in to the top of this BMP and no water go out at the bottom. That's pretty exciting. And then finally, in terms of process improvement, here is one of our earliest BMPs that in the category, earliest research projects that in the category of process improvement has saved us really millions of dollars. And the problem we were trying to address here is when you've got hundreds of construction projects going on across the state, and you've got a permit that says after every ½ inch of rainfall, you need to run out to your project and check your erosion control. Okay, that's not such a bad thing when you've got people who are permanently out there on a big project that can check the rain gauge. But we've got a ton of small construction projects going on out there. They are not people out there every day necessarily, but yet with scattered afternoon and evening thunderstorms that are very, very common in North Carolina in the summertime, we had people running all over the place checking rain gauges. So what we did here with this research is we developed, with the cooperation of North Carolina Climatic Center, a website where which the erosion control inspector can go to the site, put a pin on the map, put in their lat long representing their construction project location, and enter in what is the threshold I want to be alerted to in terms of the depth of rainfall. So if it's a ½ inch that we're required to go out and inspect our erosion control facilities on, if it rains that much, then he puts in a ½ inch, send me a text message. And that's worked great. That saved us a ton of money and avoided compliance costs. And then finally, what we do to really reinforce the relationship between research and guidance, you can see an example of this is in our BMP toolbox manual. This is our BMP design manual. And in the back of the manual, we have a table that references each BMP, relates it back to the research project that supported the design for that BMP, and gives you sort of a summary of what was learned in that research and then how that research was applied to that BMP. So you really see that direct connection between research and what we're doing in the hydraulic design. Just to kind of wrap up here quickly, one of the projects that we're going to be starting here this fall is really addressing a fundamental question, and that is, what is the right amount of stormwater treatment to your project? You know, we've got these design standards that we kind of follow, but is that really the right amount to treat? Do we need a swale? Do we need a bioswale? Do we need a wet detention basin? So we're working with USGS and the Seldom model that is developed in partnership with FHWA to answer that very question. And we appreciate the work that Susan Jones at FHWA is doing. She supplied us with some grant money to help support this research because we think that, or she thinks at least, that this has some national significance to it. Gives you an idea of how much research that we've done over the years. I won't dwell on it, but we've collected over 33,000 event mean concentrations. And I would say the mistake that we made early on is that we didn't think enough about how we're going to manage this data. And over the years, we've collected a boatload of it. And then all of a sudden we find ourselves wondering, well, what was that project that we did 7 years ago? Where's that data? So we've developed a analytical monitoring database that to now store all that data, allow us to retrieve it. It's built on the FHWA's highway runoff database schema, so it complements that really nicely. We also have business rules to ensure the security and the integrity of the data over time. So that's exciting now because we can use that data more and more and more. We've got 3 upcoming research projects this fall that we're starting off. One is an outlet analysis because we've experienced a lot of erosion of downstream channels over. We've noticed that, so we're trying to improve our guidance on how do we analyze outlets. We're looking to discover new amendments that we can add to our predominantly sandy bioretention mix to improve pollutant removal performance. We're going to do screenings of about 25 different amendments, narrow it down to the top 3. And then we're interested in optimizing how much compost is you need to apply to get the very best plant growth and infiltration. So these are just ones that are starting off. Quickly to wrap up here, is anybody familiar with the TRID database? Have you looked at that? I see a couple of hands gone up. This is the world's largest bibliographic reference to transportation research in the world. And oftentimes, and I mentioned at the start of my project, we don't know what each other is doing in the realm of research. So the other day, I put in stormwater into the database, and look what popped up. I was so surprised. Those 3 research projects that I just said are starting off, we started like 2 weeks ago. They're already in the database. I said, that's awesome. So this is a great tool. I just wanted to bring that to your attention.